the set, which is so when we rotate 180 degrees, it is also associative. It also has an identity element, which is M. It also has an inverse element, which is M. The inverse of M is M. The inverse of O is O. The inverse of 2 is 2. And the inverse of 6 is 6. So G sub 14 is also a group. So G sub 15, we have the element O48. So it's closed because all the outputs are within the set. It also positive because when we rotate the table 180 degrees, it is the same in the first table. So it is also has an inverse identity element, which is M. It also has a inverse element for all. So G sub 15 is also a group. So let's move on. In G sub 16 with an element MRO Q1T57. So here it is closed. And when we rotate it 180 degrees, it is not the same. But when we rearrange the column 2, column 4, and column 5 to column 7, it's not the same in the row, but it is the same in the column. So our models here is we need to rearrange the row. So when we arrange when we rearrange the column, it is equal to the first table. So it is also has an identity element, which is M, and it has also has an inverse element for all. So G sub 16 is also a group. So next one, G sub 17. So it is closed because all outputs are closed in our set. And when we rotate, it's not the same, but when we rearrange the column or interchange the column 1 and column 7, column 2 to column 6, column 3 to column 5, here, the result. But as what you can see, it is not the same. But when we rotate or when we interchange row 2 to row 8, row 3 to row 7, row 4 to row 6, our result is the same in the first table. So it is associative. It also has an inverse element, which is M, and it also has an inverse element for all. So our set, which is G sub 17, is also a group. Now, let's move on in G sub 18. So here, our table. It is closed, and when we rotate it, it's not the same, but when we interchange column 2 to column 4, column 5 to column 7, we have this result, which is equal or the same in the first table, so it is associative. It also has an identity element, which is M. It also has an inverse element for all. So this G sub 18 is also a group. So now let's move on in our lattice diagram. So in constructing the lattice diagram, we have to present first our improper subgroup, which is uh, the group itself, which is um, G is equal to MARCOSQT1234567 8 is a group under the binary operation. And by uh, by putting this set, we must connect it because G sub 16 has an element MROQ135 that is found also in group G. And G sub 17, the element is also included in group G. So we must connect those. It's the same also for G sub 18. So here for our four elements, so G sub 11 is must connect to G sub 16 because MO15, the element for G sub 11 is can be can also be found in G sub 16. Same goes to G12 and G13. And G13 is the elements of it is included in the G17. It's also included in G18 and G14. The elements of it is included in G18 and also for G15. So here in G2, the element of it is included in the G11, same for G3 and G6. And G4, the element of it is included in G12 and also for G5 and MO or in G6. And also the, the group uh, which is defined as the set of G6 is the element of it is included in the set or in the group G13, G sub 13. And also for G14 and for G7, and the elements within the set is included in the G14. And for G8 is also included, G sub 8 is included for G sub 14. And for MO is uh, or G6 is included in G15. Same goes to G9 and G10. So for our G1, um, we have the element of M, which is our identity, and our trivial subgroup, which is connected to all G2, G3, G4, G5, G6, G7, G8, G9, and G10. So this is our lattice diagram. This lattice diagram represents the connection of each subgroups. So that's the subgroups of my geometric model and the lattice diagram of my geometric model and my constructed. That's all. Thank you.